looks like to solve a log equation. A log equation is when the x is inside the logarithm. And we are going to use our skills to get it together as a single logarithm. So here, you have a log plus a log. There's a log law that says if you're adding two logs with the same base, that's the same as multiplying inside the logarithm. And I would get log 2 of x squared equals 2. Now, algebraically, what we're going to do next is something you've never done in solving algebra ever before in any question. And it's a little bit weird. It's a little bit weird because our next step is you are going to, I'm going to put a red star here, you are going to use the definition, there we go, to write it in exponential form. So the definition says my base is 2, my exponent is 2, and the answer is x squared. And I put a red star by that step because going from here to here, you never before in any algebra that you've ever done said, in the middle of this, I think I would like to use a definition. I'm going to pull out my thesaurus and solve this math problem. No, that doesn't ever happen in a math problem. And using the definition changes it from one form to another form, and the forms look different. Yes?
Could I also use, I found in the book the other definition for the logarithm, that log base b of x to the power of b is also x?
Yes, but for what we're going to do here, this is going to work out really nicely, okay? For a lot of these equations, there are more than one technique to use them. What I'm going to show you as the main technique is the one that I think will be the easiest overall. In some specific questions, other techniques might, well, this is easier in this case, perfectly fine. But this is what is going to be easiest overall for all of our questions that we're doing. Okay? At this step, you would have 4 equals x squared. You can obviously solve that by square rooting both sides, and you would get plus 2 and minus 2. However, we have to check your answers because you are not allowed to take the log of a negative at any time. And when you check, you have to check the original equation. So we go back to our original equation here. I plug in 2. When I plug in 2, I get log 2 of 2 and log 2 of 2. Both of those are positive numbers. That's going to be okay. But when I check negative 2, I get log 2 of negative 2 right away. You are not allowed to take the log of a negative number. You don't even have to check the other one. Once you get one negative inside of one logarithm, that answer will never work, and we put an x through it as an extraneous root. Solving log equations will always look like this. The key thing will be this definition. You'll want to use your definition. In order to use your definition, though, you have to first get a single logarithm. So this will be our starting step. We're going to use our log laws to get a single logarithm. If we get a single logarithm, that allows us to use our definition. And every time you use your definition, you will always change it into some sort of algebra thing that you've solved in the past, either grade 10, grade 11, grade 9. You'll say, oh, I've solved one like that before. I know how to do that, okay? But in order to get it into that form where you know how to solve it, you have to use the definition, which, for whatever reason, probably because it's such a weird thing, you forget, okay? Weird things are weird, especially for your memory. Sometimes if something is weird, you remember it easily. Like, oh, that person has a weird name, I remember it. But sometimes it's exactly the opposite. Oh, that person has a weird name, I have no idea what it is. Weird things work that way. Sometimes weird things you're like, I always remember it because it's weird. And sometimes you never remember it because it's weird. This is a weird thing in math, using a definition to change from a single log to exponential form. And for that reason, we often forget. And some of you, by me saying it over and 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 over again, you'll hopefully remember it. And some of you have decided that, oh, I'd probably be the one to forget it, so whenever he says it, I just don't pay attention, because I'm going to forget it anyways. Like, oh. So you really have to pay attention to that step, because it's going to happen. And once you get that step, you are going to be able to solve log equations easily, because they're very predictable. They're very predictable. How do we know it's a log equation? Because it says solve, and the x is inside of a logarithm. So we want to use the definition. But in order to use the definition, first, we have to get a single logarithm. Right now, I have two logarithms. But I could put them together because there's a log law that says if you're adding two logs with the same base, that's the same as multiplying inside of that logarithm. And then once you have that single logarithm, now here's the weird step where you use the definition. Change it to exponential form. The base is 3. The exponent is 4. And it's going to equal 9x squared. Once you've done that, you turned it into an equation that you've solved in previous years. Do you think you could get x by itself? Yes. 3 to the 4 is 81. I could divide both sides by 9. That would give me 9 equals x squared. Square root both sides, I get plus or minus 3. And then I need to check if I plug in 3 into my original equation, I would get 27 inside the first log. Positive number, perfectly fine. I'd get 3 in my second number. Positive number, perfectly fine. This one works. But if I plug in negative 3, I would get negative 27 inside my first log, and I have to X that one out as an extraneous root. The only answer is X equals 3. Questions for practice on this one? Circle 3, 4, and 9. So again, what are the main steps? First of all, you had to use your log laws to get that single logarithm. Once it has a single logarithm, that allows you to do the weird step where you use the definition to change from log form to exponential form. Once you've done that, the rest of it is like, oh, I've done one of these before. I know how to solve. So you solve for x. But in log equations, you always have to check your answers, because one of the rules of logs is you can't take the logarithm of a negative number or 0, only positive numbers, so you have to check to see if it works.